This is the first of a couple videos on examples of doing calculations involving the rate of radioactive decay. So in this problem we're told that this sample of argon-41 has an initial activity of 34,500 becquerels. Right? And so this is our initial amount of substance. So the initial amount of substance, they give it to us in grams, number of atoms, or one of the common ways that you'll see it is in activity. We're given the half-life of 110 minutes, and we want to know what the activity, or what the NT is going to be after 75 minutes. So in order to solve for NT, I need N0, which I was given. I need the time. I was given that too, the 75 minutes. And I also need the rate constant. Now, we weren't given the rate constant directly, but we have this second equation that relates the half-life to the rate constant. So I can first use this equation to get the rate constant, and then I can plug all of that into here to get the activity at 75 minutes. So the first thing we're going to do is get the rate constant. And so that comes out to be, and the units on the rate constant are always the inverse of the units on the half-life, right? So if the half-life is 110 minutes, then the units on the rate constant are going to be 1/minutes, or I could write that as minutes to the -1. Okay, so now that I know the rate constant, I can use this equation to calculate the activity at 75 minutes. So I'm solving for NT. I know the N0. And then I have E to the minus. And the time is 75 minutes. Okay? So because I just have numbers in the exponent, I can just plug this into my calculator. And so when I do that, I get a value of 0.623. All right, so I'll multiply that by the 34,500. And for my activity, I get 21,500, and the units are going to be becquerels. The NT and the N0 will always have the same units.